All notes and no play gives you homework time today. How's that? Even rhymes. Okay. So.
We're smiling. This guy must be on his death.
Did you end up calling him?
Or in his chair.
Okay. So we were talking about sign charts. So we're gonna go over that again, a couple more, because we gotta talk about a couple of course, the weird things, which we always have to talk about. Second, I gotta find my notes.
When are we getting a review?
I don't know. Some point in time. Not helpful. I don't know where my notes are.
That's good. I think today is the day of story time.
Nope.
Yeah. Look, I think today is the day you need to just rant to us about stuff.
No.
And we'll listen.
There we go. We're gonna listen. No. Okay. So we had done this. We had done this one, and we even get to the point like we talked about. You can even graph them, which is not very often. You're not gonna have to graph it on the AP test, but I just wanted to show you that you could get yourself a pretty accurate graph just based on increasing and decreasing, where the maximums and minimums are. So I believe that I just have a couple more examples, and then I'll give you homework time. Should be lovely for you. Okay, so just a second. I'm gonna find my right page. I don't want to skip anything. Sometimes I skip the things in my notes, and then I'm sad because I skipped some things. Oh, 227. All right. Okay. I want to talk to you about a couple things, a couple just terms we got to talk about. So the first thing that I want to talk about is the first derivative test. Sounds awful, but you already know what this is. Okay. So the first derivative test says just a second, that if x equals c is a critical value of f of x, then, so there's two things that we even need to talk about. And we've already talked about this, so this is not going to be anything new to you. But let me just pause and kind of reverse this with you. If we know that x equals c is a critical value, what do we know about f prime of c?
0.
Or?
Undefined.
0 or undefined, right? We know it's a critical value. Critical values are where f prime is equals 0 or is undefined. So just backwards. If we know it's a critical value, we already know the derivative is 0 or undefined. Then if f prime of x goes from negative to positive, x equals c is a minimum. Yep, relative minimum. That's the first thing. And then the second thing is if f prime of x goes from positive to negative, then x equals c is a relative maximum. So we've been talking about this since chapter 2. The first half of chapter 2, when we started talking about looking at a graph and saying, hey, I know that this 0 is a minimum. This x-intercept is a minimum because the derivative goes from positive to negative. That's a maximum, sorry. Okay, where we can look at a graph and know that. This is just formalized, we wrote it down. Now, what if f prime of x goes from positive to positive or negative to negative, then x equals c. I could slow down a little bit, sorry. Then x equals c is neither a maximum nor a minimum. Sometimes that happens, okay, where you have a graph and you do it and it, like, it's not positive, it's not. It goes positive, positive, or it goes negative, negative. That's not a maximum, it's not a minimum. Right? It's a neither. And a lot of times on the AP test, they will ask you, here's this, at x equals 1, is this a maximum, minimum, or neither? And they'll ask you why. So it's neither. The reason something would be a neither is because it doesn't change from positive to negative or negative to positive. It just keeps going positive to positive or negative to negative. We'll do an example like that in a minute. I don't like that example though. So let's do let's do this one. Okay, so we're going to find maximums and minimums. And then also the intervals of increasing and decreasing, but we're just going to go maximums and minimums. So let's say f of x is equal to x minus 4 to the 2/3. Oh, sorry, that's x squared minus 4. Whew, that makes a difference. Okay, so first step, since I know you've forgotten the things over the weekend, first step is to find the derivative and set it equal to 0. Okay, please do that.
This one's awful.
It's not a very pretty derivative. I'll give you that.
Should we factor like x squared minus 4?
Mm-hmm. Okay, what's the derivative? First, we'll go first step derivative.
4/3 times x squared minus 4 to the negative 1/3.
Oh, I got you. Okay. So 4x/3 times x squared minus 4 to the negative 2/3. Okay. So if you
1/3.
do the derivative of this, it's 2/3 x squared minus 4 to the negative 1/3 times the chain rule derivative of the inside. So that's where Mason got the 4x. It's the 2x times the 2. Okay. This drops to the bottom. So on the top, we have 4x over 3 parentheses x squared minus 4 to the 1/3. Now, Garrett asks a question, should you factor the x squared minus 4? Not up here, because you don't want to do the product rule. That would be terrible. Product double chain. No, thank you. Here you need to factor it, though. So what's that factor to?
X minus 2x plus 2. Well, you got to put your
Yeah, there's my cube roots out there. Yep. Okay. So it's 3 cube root x plus 2x minus 2.
Oh, I just put it all in parentheses to the 1/3.
That's okay too. Okay, now, what are your critical values?
0,
0
2,
and
-2.
-2. Because the bottom cannot equal 0. Okay, so this is that whole bit that critical values are where the derivative is 0 or undefined. Now, we haven't done a sign chart with a fraction, so let me talk to you about that. This is also weird. You're probably not going to like this, but this is true math, so I'm going to give it to you. If this is the cube root of x plus 2 and x minus 2, because those are multiplied, what's a 2? Didn't look like it. Because those are multiplied in there, I'm allowed to break that up into the cube root of x plus 2 and the cube root of x minus 2. That's just an exponent rule.
I left mine with negative exponents.
Don't do that.
That's not going to work.
Did you recognize it as being a critical value because it was going to be on the bottom?
It just makes it 0 if you don't recognize that.
True. Still, so it still comes out as a critical value.
I'm right for the wrong reasons.
Yeah. Should be okay. It's just going to be a little easier for you to calculate. I don't know. Okay, so let's talk about intervals anyway. Your interval is going to be x is less than -2. What's your next interval?
-2 to 0.
Yep. Next one?
0 to 2.
0 to 2. And then if x is greater than 2. So when we have a fraction here, you still do it. This is this. If you want to, like it's, all these things are on the bottom, like 1/3, because that's on the bottom, right? So it'd be like 1/3. And this would be 1 over the cube root of x plus 2 and 1 over the cube root of x minus 2. You can do it without the 1 over because it also doesn't matter, but it sometimes bothers people because they're like, it's on the bottom and I'm dividing. You're going to be multiplying by the fraction. Yes, Mason?
How come we didn't put the 1/3 before x?
You could have 4/3, 4/3 x.
Then you just have 3 things?
Yep. Then you just have 3 things. Okay, so go ahead and fill in the sign chart for me. What?
Nothing.
Okay, so you could you could put it like this, all those together, like the 4x over 3 could all be together, and that would give you one less thing to do. Which would be the smart play. I just didn't think about it. No, it's just always positive, right?
That's what I said.
Okay.
You good? Dang it. I just gotta make it real scary.
Yeah.
If you take the square root or a cube root of a negative.
2 different things. You can't do the square root of a negative, but you can do the cube root of a negative.
But you can't do it.
Correct. You can do odd roots because remember that a cube root is asking what times itself 3 times. And so it can be negative because a negative times a negative times a negative is a negative. So this is negative. This is positive. -1 would make that positive, positive, and positive. This one, negative, 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 positive. Now, I'm also going to say this to you. I hesitate to say it, but if you've done it correctly, it will never switch back. Like once it switches to positive or it starts positive and switches to negative, if you factored correctly, it won't switch again. Do you get what I'm saying? So once this hits positive, it stays positive. If you have factored correctly, because it's linear. Each of these pieces, x plus 2, x minus 2, 4x, they're all linear pieces. And so a linear only crosses the x-axis once. Okay? if you,
Can we get, like, trig
it is a good way to check your work.
Will we ever trig stuff in there? That's switch.
I've not seen it.
Would that switch if it wasn't in there?
No, because yes, it could, because it does go. But no. Yes, but I'm sorry. I'm just trying to think about my chart. You're right. Trig would switch. Trig would switch. Okay, so on the top, tell me what F prime is. Negative, positive, negative, positive.
Why is the second one positive?
Because the negatives kind of cancel.
Negative times a negative times a positive.
No, in the top one.
Negative times a negative times a negative times a positive.
Why is it?
Because there's no X.
There's no X on this. Oh, you're looking at this column. Yep. Because it's just 1/3. If you had a negative constant, if it was like a -2, it'd be all negative. Okay. Now, so this is increasing, decreasing. Oh, decreasing, increasing, decreasing, increasing. Okay. So what's going on here? Decreasing to increasing. Yep. This is a minimum at X equals -2. What's here? Yep. Yep. Maximum at 0. Another minimum. Okay. Let's do this one. This time, now that we're into this, we're going to do this example. We're going to do one more. So 2 more. This one I'm giving you F prime already, though. Okay. I would like you to find maximums and minimums. Please. Maximum and minimum. Okay, it's already F prime. Make sure that you catch that it's already F prime. Just like that. We don't have any ways to find the actual points.
That's what I thought.
We're doing
another
Making sure
example
they miss
after
it.
this. We are not.
Wait, is there a way to backwards
David, it's already F prime.
Oh.
It's already F prime.
Oh, that makes a lot of sense.
You're
Yeah.
such a silly goose, David. All right.
Next. I'm just too easy. Just
Bless you.
we have to like
Oh, do not explain.
That's the word I was. X minus 2. I don't believe her. Yeah, 6 minus 3 squared.
Yeah,
So
the square
we're
was
gonna
on the
grab-
inside, the square was on the
I just exactly. So the graph is E on the top, X minus 2, and X minus 3. 2 X minus 3 but the same thing.
Oh, you can do either.
I'm trying to.
Okay,
Okay, so I'm trying to think. As per usual.
I feel like there's 3.
As per usual.
We're
talking about that.
But it's already a factor. So now, that just means that the choice is X minus 3, X minus 2.
You should stop talking and have
But how many critical values does it generate? Or just one?
So why do we do that?
Mind your business. Talking about something else.
Can we give you 2 though? If you.
Oh, no. No, that's not what that means. No, that's not what that means.
You silly.
Is it a difference of squares or is it just X squared?
That's just X. You guys, listen. This is not, okay, this is not difference of squares. Okay? Difference of, this is, look, difference of squares would look like this. That's different. Okay? This means there's 2x minus 3's. Like, yep, this could be rewritten as x minus 2, x minus 3, x minus 3. That's what x minus 3 squared means.
So on top, there should be 2 X minus 3.
There's multiple ways to do that, but you can do it that way.
Okay. Well, you can just make it 1 and just have square brackets.
Correct.
Still gonna be-
That would be the other way.
I don't want to do that.
Okay.
So there are two of them.
Like, I don't know.
Well, okay, so then let me ask you this
I don't
question.
know if
If you
it's-
just have this,
It's like you-
is that the same?
I have magnet scrolls. I have a 18 of them.
There's no other secret.
What does that have to do with Jess?
David, why
I'm
are you?
done.
I don't really want to hear you talking.
We're not all done.
You're distracting other people. Okay, so how many critical values do we have? What are they?
2 and 3.
2 and 3. So, you guys, the difference between, again, I said that's on the board, but this one up here is the difference of squares, because the squared is actually on the x. This is just means 2 of those things. So your intervals should be x is less than 2, x is between 2 and 3, and x is greater than 3. Now, this is the other question I got. Do you have to have 2 x minus 3s? If you are going to separate this, then yes. Okay.
Otherwise, your rule thingy with the switching doesn't hold true anymore, right?
Does it?
No, it doesn't.
I think it doesn't.
Why Remington?
Well, because it's gonna be a negative and then a negative, so then it's gonna be positive.
Something squared is always positive.
If you split it, it's gonna be negative.
Correct.
Indeed.
Okay.
Why would I need to write?
So you can do that with the even powers. Can't do it with the odd powers. So if you're like, nope, don't want to remember that, then write them all out. Okay, so this is going to be, if I plug in something less than 2, that would be 0. So negative, this is going to be positive. This is going to be positive, positive, always positive. Okay, so in this first interval, f prime is what? Negative, and then it's positive, positive. Okay, so what's happening here?
Decreasing. Oh, we're talking about the in-between.
Oh, well, so this is decreasing, increasing, increasing. There we go. So at x equals 2, maximum, minimum, or neither? Minimum. You go from decreasing to increasing, so minimum. Okay. At x equals 3,
Neither.
it's neither. It is a critical value, which means the derivative equals 0 there, or it's undefined. It's 0 in this case. But the derivative doesn't change sign, right? The derivative goes from increasing to increasing. The way that might happen in a graph, this is not necessarily this graph because it's not increasing. And I can't even draw it this direction, but like you're looking at something like this. Sorry, that should be flat. No, like it flattens and then it keeps going up, like in an x curve, in an x cubed thing.
That counts as a critical value.
The derivative is 0. Okay.
Your new stem, the yes. I like it. What if it's like, my ex is still not that I went to my vocabulary.
From a certain point to another point.
Then it would, then that's different. Okay.
So like we don't get that, I don't have one.
Okay.
Alright, homework.
Nope. Shoot.
What's the plan originally? Because there's no way we were on that Sunday.
I can't find a blank page. Oh, there we go. Okay. Last one. This one is going to be harder. Over
It's
X.
gonna take 10 minutes.
Oh.
I have.
Whoop. Quotient rule indeed.
You guys how to do it?
I don't think that's how they do it.
Oh, wait, you already did it?
I'm gonna.
A derivative?
Okay.
Oh, wow.
Yeah, you're welcome. So this is 4x to the 5th minus 2x to the 5th minus 2x. So the top of this, I just did the derivative for you, is 2x to the 5th minus 2x over x to the 4th. We're not done yet, but what do you need to do? Well,
Take out a net.
and
Uh,
2. Let's take out a 2x. Okay, that leaves us with what?
X to the 4th minus 1.
Yes, over x to the 4th. Okay, so when I simplify, we have 2 x to the 4th minus 1 over x to the 3rd. You guys follow? Now, that x to the 4th minus 1 factors. Nope. That's a difference of squares.
Oh, is it x squared minus 1 x squared?
Yep, so it's x squared plus 1,
Which is also a difference.
x squared minus
It's
1,
also different squares.
which that's also a difference of squares. So x squared plus 1. What's this guy factor to?
X plus 1, x minus 1.
Over x to the 3rd.
Is that plus 1 we can't?
No,
Because it's not a difference.
Positive is positive.
Okay, now, here's what I want you to just pause and think about. I would like the critical values of this. Okay, so take a minute, see if you can figure out the critical values.
I appreciate you giving us the derivative.
Yeah, I'm trying to at least get you a little bit of time.
Yeah, this was take the rest of the class.
No giving up.
0.
And just pick which one we're gonna put that 2 with, so that we don't have to worry about it.
Yeah, I just want you to find the critical values first, though. Okay, so critical values 1 and negative 1.
And 0.
No,
Not on the bottom.
nope.
What? Oh, wait. What?
This is that weird business that we were talking about last week. Look at the original. Okay. If it's not in the original, like this here, this is a true statement. This is our function, but x cannot equal 0 because that would make the bottom 0. This is the bizarre thing, though. While it's not considered a critical value, we still have to use it in the table. Okay, so listen, the difference in the question would be, is a 0 a critical value? The answer is no. Okay, so if that's the question, find the critical values of f of x, it's only 1 and negative 1. Okay, because 0 is not in the domain of the original function. But I want you to think about when it's 0 on the bottom, what does that create in a graph? It creates an asymptote, and there's definitely a change from increasing to decreasing. Okay, like an asymptote goes increasing to decreasing potentially. Okay, so we still have to include 0 as a critical value. No, I don't want to say that. In our chart.
Honorary.
He's an honorary chart member, but not a critical value. Oh, negative 1 to 0. 0 to 1. Yeah.
What if it wasn't 0 and it was like a squared on the bottom and like a negative?
Give me an example that you're thinking of.
I don't think there could be one.
Okay.
Why do you have to do that? It could switch directions up there.
It looks like a W, but it's not connected.
Mm-hmm.
Oh my days, bro.
And not gonna be
out.
It's just more like.
Sounds like a fun side.
If it was easier, can we split the two in the first?
Nah, I'm going.
Put the 2 with whatever one you want. or by itself.
I think I'm
Like,
sick.
just have it two by itself.
Okay, you can put the 2 with first one, like that, or you can put the 2 by itself if you would rather. It's fine. Like if that makes more sense to you, do it that way.
Could you put the 2 over the X?
Yep. Put them wherever you want. Okay, so the 2 is always positive if you separated him because he's positive 2. How about x squared plus 1? Always positive, right? Because anything squared is always positive. And then you're adding 1, so he's still positive. So those are the only ones you got to think about. And also x cubed, that's pretty easy because you don't have to add or subtract anything. So negative, negative, positive, positive. Let's see. Negative 2 would be negative, negative. Negative 1/2, positive, negative. Positive 1/2, positive, positive. Oh, negative. There we go. And positive, positive. Okay, so f prime. Negative, positive, negative, positive.
Why do you know what 1 over X cubed looks like?
I don't know what he looks like, but he's just x cubed, right? X cubed is positive or negative, as whatever the case may be, right? If you're cubing a negative, it's negative.
Oh, I see what
If you're cubing a positive, it's positive. Okay. So here you go. This is the weirdness of this. This is decreasing, increasing, decreasing, increasing. So x equals negative 1, minimum. X equals positive 1, also a minimum.
Don't do the middle.
And we don't do 0 because 0 is not defined.
But you say it's an asymptote going down,
You don't have to say anything.
which could.
No,
Okay.
No.
Is it?
just give me this and call it good. Okay, so we need it. We need the 0 because it divides this interval right here. If I didn't include the 0, we'd run into that problem of, wait a second, if I pick this number, it's positive, but if I pick this number, it's negative. So the 0 is only there for the sake of the chart because things happen there. It's an asymptote. Here's this what the graph looks like. Like this. Look, there you go. It's a vertical asymptote. It has 2 minima, or it has two minima, and then, but there's no maximum because it's an asymptote. It doesn't have a maximum. It just jumps over and starts decreasing. So it's increasing here, jumps over, and it's decreasing. Okay, so you gotta use these guys that are not in the domain. You still have to use them in the chart, but they're not a maximum or a minimum. Okay, that's the most confusing part about this whole thing. Okay, so that's all I got for you. Not a lot of homework time, I'm sorry, but it's better than nothing. So, page 233.
To compensate for not a lot of homework time, we should have no homework. I would say that it is almost equivalent to nothing, because by the time I get to thinking about it, I'm already done.
That is not my problem.
No, I know.
Okay. If you are Gold Star Club, you may take off 26.
I thought you were about to say like take off the day before homework.
Nope.
Here's the problem.
Oh, sorry.
Great idea there.
Yeah, not.
Yeah, actually, but only gonna take 10 minutes.
You're gonna open up your book, it's gonna be A, B, and C.
Nope, it's not. 98 is, but it's the same stuff we've been doing. Yes.
Question.
Yes.
Why is it that when you divide by 0, it's not equal to infinity?
Because infinity is only there if it's limit based, which is weird. So just when we stop everything, I'll answer that question.